Hello everyone, I welcome you all to this class. This is mathematics class, and today we'll be looking at the third example on this topic we introduced in our previous classes, the limit of functions. So, and I told you that I'll be showing you how to evaluate the limits of real valued function of real variables with the help of some examples. So in our second example, we saw Hopital's rule. We used Hopital's rule to evaluate limits of functions, whereby you are getting 0 over 0 when you substitute the points you are evaluating the limit at. Then we use Hopital's rule to evaluate such limits. We will see some of them in this example we are all going to consider today. So let's look at these two questions on the board here. Let's evaluate the limits. So for the question A, we are given limit as x goes to 5 of f of x minus f of 5, all divided by x minus 5. This will be limit as x goes to 5 of, this is the question given to us, that's what I write. Then they told us that f of x is what? Square root of x. So instead of this f of x, I will put square root of x minus, they say f of what? 5, which means the value of your function when x is what? 5. So we'll put 5 here. You'll now be having square root of 5, all divided by what? X minus 5. So this will be equal to, remember, in our first class, I told you that if you're evaluating limit of function, you substitute the point. We're evaluating the limits as x goes towards 5. So we'll replace x with 5 anywhere we see it. So we have, instead of square root of x, we have square root of 5. Square root of 5 minus, we have, what's the next thing we have here? Again, we have square root of 5. All divided by, what do we have down here? X minus 5. But our x, we are putting x for what? 5. So we have 5 minus 5. This, the numerator is giving us 0 and the denominator is giving us what? 0. Because square root of 5 minus square root of 5 is 0 and 5 minus 5 is 0. So we got 0 over 0. So if you get 0 over 0, that's not the answer. We don't know the value for 0 over 0. It's indeterminate. So you use the Hopital's. So using Hopital's, we use the Hopital's rule. So by the Hopital's rule, you are going to do what? Differentiate the numerator and differentiate what? The denominator separately. So we will differentiate the numerator. This is the numerator. Numerator is square root of x minus square root of 5. We'll differentiate it at the numerator, then we'll differentiate the denominator at the denominator. So let's write the limits. Limit as x goes to 5 of, we differentiate square root of x. Square root of x is the same thing as, square root of x is the same as x raised to power half. So if you want to differentiate, you bring down the power is what? Half. You now write your x, you remove 1 from the power, that's half minus 1. I'm removing 1 from the power. You bring down the power, you remove 1 from the power. That's how we differentiate. So this will be 1 over 2 x raised to power. Well, half minus half is minus half. Minus half. So that's what we'll have. So if you want to remove this minus on x, you are going to introduce what? Using the law of indices, you introduce 1 over. So we'll have 1 over 2, 1 over x raised to power half. Right? That's what we'll have. So this will be 1 over 2 times, because if you multiply, because we have multiplication here, 1 times 1 is 1, 2 times x raised to power half will be 2 x raised to power what? Half. So that's what we have. So we have 1 over 2 x raised to power half. That's the derivative of square root of x. Then derivative of minus square root of 5 is 0, because it's a constant. Derivative of constant is 0. Then if you differentiate x using the same process we use here, if you differentiate x, you get what? 1. And if you differentiate minus 5, you get what? 0. So the answer we got in our derivative is that. So this place we have limit as x goes to 5 of what we're supposed to put here is 1 over 2 x raised to power half is the same as square root of x. Square root of x. Then square root of x divided by 1 is what we have. So I've cleaned this place because we're supposed to write limit first. Then this quantity, the derivative of this gave us this, and the derivative of this gave us 1. So if you substitute the point is what? X is going to 5. So we substitute x for 5. Replace x for 5 here. So we have 1 over 2 square root of 5 divided by 1, which is 1 over 2 square root of 5. So this gives us the result of this. So for the b parts, we have limit as x goes to 0 of 1 minus cosine of x, all divided by x raised to power 2. So if you evaluate the point x is going towards 0, you put x for 0 here, you have 1 minus cosine of 0, all divided by 0 squared. So I'll replace x for the point 0. So this is 1 minus cosine of 0. Cosine 0 is what? Cosine 0 is 1. I have 1 minus 1. Then 0 squared is 0. So 1 minus 1 is 0. We have 0 over 0. So we have 0 over 0. We use Hospital's rule to resolve it. So making use of the Hospital's rule, using the Hospital's rule, we're going to have limits as x goes to 0 of 1 minus cosine of x divided by x raised to power 2 to be equals to limit as x goes to 0. So I just recopied what we have here, right? Because we got 0 over 0, we are going to resolve this issue using the Hospital's rule. So by the Hospital's rule, you differentiate the numerator. So what we have at the numerator, we have 1 minus cosine x. If you differentiate to 1, you are going to get 0 plus. If you differentiate minus cosine, you are going to have positive sign. So positive sign x divided by, if you differentiate x raised to power 2, if you bring down the power, you are going to have what? 2. If you minus 1 from the power, minus 1 from 2, so you have x raised to power 1, which is 2x. So if you put the point again, if you put x for 0 here, you are going to have what? Sine 0. You are going to have sine 0 over 2 times 0, right? If you put the point for x here. So this sine 0 is what? 0. 2 times 0 is 0. So you will get 0 over 0 again. So I'm going to apply the Hospital's rule again. So we're going to use Hospital's rule again to resolve it. So if you are solving limit problem, if you are still getting 0 over 0, you use Hospital's rule to resolve it till the limit, the final limit result is gotten. So this what we have will be limit as x goes to 0 of. Then we know that 0 plus sine x is sine x, right? So by Hospital's rule, you differentiate the numerator. If you differentiate sine x, you are going to get positive cosine of x. Then if you differentiate 2x, you differentiate the denominator. That's 2x. If you differentiate 2x, you get 2. So if you plug in the point 0, you are going to have cos 0 divided by 2. Cos 0 is 1 divided by 2. So we got a number. We got half. This gives us what? The limit of this very function as x goes to 0. So thank you so much for being part of this class. See you in our upcoming class. Bye.